Imagine you have a quantum particle, let's say an electron, which is constantly moving and changing states, like flipping between different energy levels. Now, quantum mechanics tells us that this electron can exist in a state of uncertainty. It's both here and there, in a superposition of multiple possibilities. But here's where things get wacky. Let's say you decide to measure the electron's position, like really measure it, check where it is. Normally, you'd expect that after a while, the electron might move or change its state, as things in the quantum world are always in flux. But what if you keep measuring it constantly? Now, instead of letting the electron go on its merry way, you keep observing it again and again. Every time you measure it, you're forcing it to choose a position, essentially collapsing its wave function. So what happens? This is where it gets weird and funny. The more you measure the electron, the less likely it is to change states. Essentially, you can freeze the particle in its current state just by constantly observing it. It's as if the electron says, okay, I'll stay put. Stop looking at me. This phenomenon is called the quantum Zeno effect. It's like quantum particles are afraid to move if you're always watching them. They're stuck in a perpetual pause state, unable to evolve or change because you're observing them so much. It's like trying to speed up a car by constantly putting on the brakes. It just never gets anywhere. So, in a weird quantum sort of way, the act of observing the electron is stopping it from evolving. In the classical world, we assume that just watching something doesn't change its behavior. But in quantum mechanics, it's like you're interfering with the very nature of the particle. Now, you might be thinking, that sounds cool, but does this happen in real life? Well, yes and no. The Zeno effect works in certain controlled quantum experiments, but in the macroscopic world we live in, it's much harder to observe. You can't just keep staring at your coffee to prevent it from cooling down. Sadly, that's not how physics works. However, the idea is really mind-bending and raises interesting questions about the role of the observer in quantum mechanics. Are we in control of the universe just by looking at it? And is reality simply waiting for us to stop staring so it can evolve? Could quantum mechanics be telling us that the more we try to control the future, the less we actually experience change? The quantum Zeno effect essentially says that observation freezes evolution, making the particle act as if it's in some sort of quantum limbo. It's a fascinating and somewhat humorous paradox that shows how our role as observers can literally change the state of the universe. So the next time you're caught staring at something, remember, maybe you're just trying to keep it in a perpetual state of observation, like a quantum particle on pause. This paradox is a little mind-bending, but also hilarious in how it shows just how much power observation has in the quantum world. Quantum mechanics never fails to make us laugh and scratch our heads.